Hey guys, so in this video we're going to go over all things graphing. So we're going to look at graphs of exponentials, logs, trig, transformations, polynomials, really anything where they could ask us to graph, that's our focus today. And graphing, the devil is in the details. You have to be careful with putting arrows, making sure that things touch versus cross, making sure that things are labeled correctly. All of that is stuff that's really going to matter. So that's where we're going to sort of start our research today. So for the first one, the zeros of a quartic polynomial function are -3, 0, and ±4. Sketch a graph of each of x on the grid. So let's start with this. First of all, it tells me the zeros. So that should be the places where this function equals 0. Notice that I have 1, 2, 3, 4. There are 2 there. That is both -4 and +4. So that tells me that I have 4 zeros. Now, the other thing that I know is that this is a quartic function. Notice quart in there. That should make you think 4. So this has a degree of 4. Again, it will have 4 zeros. That's what that means. So we're going to sketch a graph of this. So I'm going to start by putting my x and y axis on here. And unless we see otherwise, we're going to assume our scale is 1. So there's my x-axis and my y-axis. I need my zeros to be at these 4 values. So I'm going to go ahead and mark where those zeros are. Now, -3 would be the first one. 0 would be the second one. -4 and 1, 2, 3, +4. So there's my 4 zeros. It does not tell me whether my end behavior needs to be positive or negative, but since I know that it's an even degree, I know it either needs to be up, up, or down, down. So you have 2 different options of what you could do here. You could say, okay, let's go cross, 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 and go up, up. Or it would be equally correct to go cross, 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 and go down, down. Both of those are correct. Both of them are quartic. Both of them have zeros at the given places. The only difference is that one has a positive leading coefficient and one has a negative leading coefficient. Now notice on this, I put arrows on the end. These are functions. They continue on. So be careful with stuff like that. You don't want to have closed intervals unless that is a limited domain or whether we have some other restriction like that. Okay, for the next one, the x value of which functions, x-intercept is larger, f or h. So f is right here. And I'm going to sketch what we would see on our calculator if we graph this because I can't pull my calculator up right now. But f of x equals log x minus 4 would be a regular log function that's gotten shifted to the right 4. So instead of having a normal x-intercept at 1, this will have an x-intercept at 5. It got shifted to the right 5. So this is 5, 0. Now you could find that from the table, or you could find that from looking at the graph and doing second calc 0, right? Now this one got cut off, but I'm going to recopy this table. So x and h of x should be -1, 6, 0, 4, 1, 2, 2, 0, and 3, -2. So again, if we think about this graph, and you could sketch it if it helps you, right? -1, 6, 0, 4, that's a y-intercept. 1, 2, 2, 0, 3, -2. That x-intercept is right here. So here's my x-intercept. Now, which has a larger x value? So f of x, this was my x-intercept. H of x, 2 was my x-intercept. So here I would say f of x has a larger x-intercept. Okay, let's look at the next one. So sketch a graph that has the following characteristics. 3 real zeros, so that means it should cross my axis 3 times. And as x approaches -infinity, remember that means left. F of x approaches -infinity, it should go down. As x approaches +infinity, that means right. F of x approaches +infinity, that means up. The thing to remember about this is f of x is your y value. So that's always going to be up or down. X is always going to be left or right. So that's really what I know here. So let's think about this. 3 real zeros. So I'm going to sketch on my x-axis and my y-axis. 3 real zeros, it doesn't really matter where they are. So 1, 2, 3. I know to the left it needs to go down. I know to the right it needs to go up. And then I can just connect those. Okay, cool. Let's keep this train moving. Let's look at this next one. Write an equation for the function shown. And notice here, they didn't give you any options, right? So you really need to understand what's going on here. Well, I know that this is a trig graph, right? And so let's start with, well, is it sine or is it cosine? So looking at this, I see that its y-intercept is at its maximum. And to me, that means it is cosine. So y equals blank cos blank x plus blank. Now, remember, this is your amplitude and this is your midline. So let's start with those. Those are normally the easier ones. Amplitude here is going to be from the center to the top. So that's a half or 0.5. The midline is the center. So that's 0. You don't really need anything there, but I'm going to keep it there. And what is the b value? Now remember, that's the frequency, which is 2 pi over the period. So looking at this graph, from 0 to pi is the length of one wave, right? So the period of this graph equals pi, because that's one wavelength, right? And so this is going to be 2 pi over pi. And so that value will be a 2. Now the other way I know this is, remember that the frequency is the number of curves you could fit from 0 to 2 pi. And from 0 to pi, I could fit 1. So from 0 to 2 pi, I could fit 2. So final answer, you could leave it like that, or you could have y equals 1/2 cos 2x. And I'm going to do a special focus video after this just on graphing trig graphs, because I know that's something we've had some questions about. Okay, the next one says sketch an angle that measures 5 pi over 2 radians. Now, there's a couple different ways to do this. So I want to talk about how to convert it, and then I want to talk about doing it more intuitively. So converting, I want you to think about the fact that what we're doing is we're canceling units, right? So 5 pi over 2, this is currently in radians, and I'm going to multiply by some kind of fraction. Now, I want the radians to cancel, so that's going to need to go in the denominator, and we're going to do degrees in the numerator. Now, on your reference sheet, it gives you the conversion factor. We're either going to do 180 over pi or pi over 180. Since we want radians to cancel, we need that to be on the bottom. So I'm going to do 180 over pi here. So in this case, I can see that the pi's will cancel. So I'm going to do 5 times 180 and divide it by 2, and that's going to be 450 degrees. So that will land me, all right, 360 degrees around is right here, and I need to go another 90 degrees, so it would land me right there. Now, let's say you want to think about this more intuitively. Remember that we said that 1 pi is 180 degrees, right? And so 5 over 2 is really 2.5 pi. So this is 1 pi, and then 2 pi, and then 2.5 pi. And that would lead me to right there. So again, another way, to do this is to think about it more intuitively. All right, which one of these is false about log base 6 of x? So I'm going to sketch that right now. So your calculator is going to show something like this. What we need to remember is that graphing calculators have a limit to what they can show. And so remember that with any log function, you have a vertical asymptote, and ours happens to be the y-axis right now, right? So it keeps going down there, it approaches it, but doesn't hit it. Now, let's see which one of these are true. So the asymptote is y equals 0. Well, there is an asymptote. It's this line. Is that y equals 0? Maybe I'm not sure about that. So let's skip it and come back to it. The graph has no y-intercept. Well, that is true because remember, if this is our asymptote, we never cross the y-axis. So that one's true. The domain is all positive reals. Well, since we can't hit 0, but it's everything other than that, that's true. And the range is all real numbers. Well, this goes down forever, and this is going to keep going up. So that is true. So A has to be the one that's false. Now, what I would remember here is that the y-axis is really x equals 0. The x-axis is really y equals 0. And so that's what I'm looking to remember here. Okay, so that's the best way to tell that that's the one that's true. This next one, our goal is to write an equation in standard form for this function. And remember, standard form means it needs to be multiplied out, right? So let's start by finding our zeros. So our zeros are at -3, +2, and +3. And so 3 zeros, I'm going to need 3 factors here. So remember, write an equation means I need a p of x equals. And then this would be x plus 3 for this one. And then this would be an x minus 3. And then an x minus 2. So remember, when you go into the factor, flip the sign. Now that is in factored form, it is not in standard form. So in standard form, we're going to need to multiply these together. I'm going to start by multiplying these two together, and you're going to either do box method or double distribution. That comes out to be x squared minus 9. And then from there, I'm going to go and multiply what's left together. So x squared minus 9 times x minus 2. And that's going to give me x cubed minus 2x squared minus 9x and then plus 18. And that would be written in standard form. Remember, whenever we multiply 3 things together, pick 2 to multiply and then just multiply the third by your product. Okay, so for this next one, given 2 to the x and 11 minus 2x, solve for x to the nearest tenth graphically. So what that means, I need to look at the graph. So I am going to look at my graphing calculator, and I've got one of them in blue, so that's 2 to the x, and then the red one is 11 minus 2x. So those are my equations here. I'm trying to find the location of that intersect. Now, this is a little bit different operating system, so let's talk through how to do this on yours. So on yours, here's what you would do. You would hit second, and then trace, because you want to calculate. And then you are looking for 5, which is the intersect. And from there, you would do like enter, 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 do where you think it intersects. Again, if you need help with that, go to my calculator help video. And it comes out to be something about that. To the nearest tenth, that would be 2.6. So for this next one, we're going to sketch a possible function for p of x, where we have x minus a, x minus b, x plus c, and a and b are positive numbers. A is greater than b, and p of x has a positive y-intercept of d. So let's see what we know here. So first of all, this means if these are my 3 factors, that my zeros would be at x equals a, x equals b, and x equals negative c. And they tell me a and b are positive numbers, so these are both going to be on the positive side. That's going to be on the negative side. So let's start with this. I'm going to graph these. And again, it's a sketch. It doesn't need to be perfect. And they tell me a is greater than b. So I know I should have 2 over here. But a is greater than b, so a should be further to the right than b. Now, c is going to go on the other side. So I'm going to put that over here. And then they tell me that the y-intercept should be d. Now notice, none of those multiplicities are even. There's nothing weird about them. They're all just to the first. So now all I'm going to do is sort of connect those points. So it's going to come up, come down, come up. Notice it's crossing at every one. And then I'm putting arrows on the end. All right, next one. Sketch at least one cycle of a sine curve with an amplitude of 3, a midline of -3/2, and a period of 2 pi. And then it says explain any differences between y equals 3 sine x minus pi over 3 minus 3/2 and the sketch in part A. So let's start by sketching part A. So it says it's a sine curve. So sine tells me it's going to start from its midline. Right, its y-intercept should be at its midline. It has an amplitude of 3, a midline of -1.5, and a period of 2 pi. So here's what I know. I know that my midline should be at -1.5. So let's say that's -1. This would be -2. My midline is going to be right through here. Now, from there, we know it needs to have an amplitude of 3. We knew that our midline was -3/2. And I know that the period is 2 pi, which tells me that from where it starts to where it ends should be 2 pi. So that should complete one full curve there. And remember, we always sort of divided this into 4 parts. Now, think about that. If that's 2 pi, this is 1 pi. And you could keep labeling this pi over 2, and then 1.5 pi or 3 pi over 2. Okay, so let's see what we know now. So we know that the amplitude should be 3. So sine curves will start from their midline. It will go up 3, so that's 1. Just labeling those. This should go up to 1.5. It should come back down to its midline and then go down that amplitude. So -3, -4, -5. It should be right between those. And then go back up to its midline. So it should look like this. Hopefully that's easier for you to connect on paper than it is for me on here. So that would be what that looks like. And that's one cycle of this curve. Okay. Now again, if you're struggling with this, I'm going to do a special focus whole video on this that'll be up after this video. So now explain any differences between this and 3 sine x minus pi over 3 minus 3 over 2. So let's write an equation for this. So I know it's going to be y equals 3 sine. I know it's going to be minus 3 over 2. But let's talk about what should go in here. How do I get my b value? So to get b, I'm going to do 2 pi over the period, which is just 1. So the only difference between these two functions is this minus pi over 3. And so what that should make you think is, oh, that's an inside change, horizontal inside, vertical outside. So this is shifted to the right, pi over 3. Okay, let's do another trig graph because I know this is something we still have some questions about. So, okay, on the axis below, graph one cycle of a cosine function with an amplitude of 2, a period of pi over 4, a midline of -1, and passing through 0, 1. So first of all, I know this is a cosine curve. I know A should be 2. I know that C should be -1 because it's shifted down 1. Midline is -1. And I know that B should be 2 pi over the period, which would be 2 pi times 4 over pi, which is 8. So the equation of this should be y equals 3 cosine 8x minus 1. Oh, I'm sorry, amplitude of 2. So it should be 2 cosine 8x minus 1. Now from there, you could put it in your calculator to look at it, but let's actually graph this. So I know that my midline is at -1, right? So that's my middle. And from there, I'm just going to assume that this has a scale of 1. Now, what about the scale on the x-axis? This tends to be what people goof on. So remember when we did this, and you don't have to do it this way, but sort of the easy way to keep it spaced is to go out 8 boxes, so 1, 2, 3, 4, 5, 6, 7, 8, and sort of section that off into quarters. You don't have to do it this way, but that's sort of the easiest way for me to do it. I know that the period should be pi over 4. And then, I mean, you could keep dividing this. This would be pi over 8, right? Half of a fourth. And then you could keep going from there. But that should be your basic setup. Now, I know it's a cosine curve. I know the amplitude is 2. So it starts at its maximum there, right? Or 0, 1, sorry. It starts at its maximum because that's up 2 from its midline. So this is going to start at its maximum, go to its midline, go down to its minimum, go back up to its midline, and go back up to its maximum. And remember, a cosine curve should look smooth. It should sort of flatten out near the top. It should never be pointy, right? Good. And remember that you can always check on your calculator if you can write the equation of that. If you feel like this is something you're still struggling with, please come see me or go to that other video and take a look at it. Okay, let's look at this next one. So which of the following is not equivalent? Now, again, why did I put this in the graphing section? Well, because what I would do here is if I want to know if these are equivalent, is I would graph this one, and then I would graph each of these, and I would see which graphs are the same or see which tables come out to be the same. So the first one, if you just distribute that out, you will get A. So that is equivalent. On the second one, we're doing a power to a power. We could multiply. Those would be equivalent. The third one, it's a negative exponent. And so we could just flip that. Those are equivalent. So I know it has to be D. But again, look at the graphs. If the graphs match, they have to be equivalent. Okay, let's look at this next one. So it's graph this function on the set of axes below. And notice that those are labeled for me, sort of pre-labeled. But I'm going to actually bring in a finished graph because I want to look at what this should look like. So here's the finished graph, and there's a couple things I want you to notice. Number one, to graph this, I'm not doing anything crazy. I'm looking at the table on my calculator to get these values out, and I'm plotting it on this graph. Now, I noticed down here this was counting every 1, 2, 3, 4, 5 boxes were 100, so I just continued that up to 200, 300, and then 400. Now, similarly down here, this started at 1, so I knew that every 2 boxes was going to be another 1. So it's going to help you to label those, right, to make sure that you know where you're graphing. And then from there, just estimate these as best you can. Obviously, they're not going to be perfect, but estimate them to the best of your ability. Also, if this was a word problem, I would make sure that you had labeled your axes, right? Here it was just graph the function, so we didn't need to do that. Okay, next one. A graph of y equals f of x is shown. The function has a leading coefficient of 1. Write an equation for f. Now notice it does not say in any particular form. So I would leave it in the simplest form you can. Now let's look here. I see 1, 2, 3 zeros. But notice that my end behavior is up, up. So that seems weird that I would have an odd number of zeros. And that's going to have to do with my multiplicity. Here it touches, or I'm sorry, it crosses. Let's erase that. Maybe. All right. Here it crosses, so that should be odd. Here it touches, so that should be even. Here it crosses, so that should be odd. So let's look at this. I'm going to say f of x equals 3 factors. So this one hits at -4, so that's going to be x plus 4. That's this. This one hits at 0, so x minus 0. This one hits at 3, so x minus 3. Now this one could also be x plus 0. It's the same. Doesn't really matter. Now this one should be odd. I'm going to leave that as a 1. This one should be odd. I'm going to leave that as a 1. But this one should be even, and so I'm going to make that a 2. And this would be your equation for f of x. Now the second part says shift this all to the left 2. So the easiest way for me to do that is really just to graph each of those shifted to the left 2, and then think about redrawing that same function. So this would be g of x equals x plus 6, x plus 2 squared, and then x minus 1. So same idea there. Okay, next one. Graph y equals log base 2x plus 3 minus 5 on the set of axes. Use the appropriate scale to include both x and y intercepts. Describe the behavior as x approaches -3 and as x approaches positive infinity. Again, I'm going to bring in a finished graph so we can take a look at this. So the big thing you want to remember with logs is that even if your calculator doesn't show it, there will always be a vertical asymptote. So what I need to be careful of here is not cutting my graph off too early. So let's start with the table. I see that I get an error at -3. Well, that's because normally my asymptote is the x-axis, right? And here this has been shifted to the left 3. So I'm going to get an error there. Now, 0, 3, 6, 9, 12, and again, you could graph by some other scale, but what I want to be able to do is fit my y-intercept and my x-intercept. I see my x-intercept is going to be somewhere between 27 and 30, so I'm going to count by 3s to make this able to fit. So that's where I got that scale. Now, for my y-intercept, I see here that that's really just somewhere between -3 and -4, so I don't need any crazy scale here. But then I'm going to graph those points. Now, as far as describing this, here's what we need to think about. As x approaches -3. So here's -3 right here. As x approaches -3, what does the function do? The function goes down forever, right? So as x approaches -3, f of x approaches -infinity. And then as x approaches infinity, what does f of x do? Well, this is going up, 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 up. So that would approach positive infinity also. So it would be good if you could at least write that in words or, write it symbolically too. Okay, and then the last question in the graphing review. What is the solution to the system of equations y equals 3x minus 2 and y equals g of x, where g of x is defined by this function below? So let's take a look at this. I have this function and I have y equals 3x minus 2. Easiest way to see the solution is to see where they intersect. So let's start by graphing this line. Now, if you were stuck, you could put this in your calculator, look at the table, but I know that this will have a y-intercept of negative 2, and then go up 3 over 1, up 3 over 1, up 1, 2, 3 over 1, up 1, 2, 3 over 1. So I know if I actually graph that line, it's going to look sort of like that. And on the regions, remember that you'll have a straight edge, right? So I wind up getting my solutions to be x equals 1 and x equals 6. That's where these would actually intersect, right? At 1 and then 2, 3, 4, 5, 6. Okay. Now, we know that to get the y values, we would have to plug back in or to just look at where they intersect. So here, that one is at 1, 1. And so I can already tell it's D. And this one, I can't actually see where they intersect at 6. But once you know that that's 1, 1, you could assume that that would be 6, 16. So just don't be afraid. Like when I did this one, I saw that this definitely went up off the graph, right? Negative 2 up 3 over 1. But that's the only one that had an intersection at 1, 1. And so automatically I could eliminate all these other answer choices. So again, graph it and go from there. Okay? So this should be a quick summary of graphing. Make sure you're labeling scales. Make sure you're labeling axes. Make sure you're putting closed endpoints or open endpoints, depending on what they ask you for. And you guys are going to be great. If you need more help with trig graphs, go look at that special focus video. And otherwise, I'll see you in the next one.